Okay, today is May 9th, 2019. We have a 9-question review of different chapters in your book. We'll go through this. So if you're using this as a study guide here in June, you can press pause on any question you want to see if you could solve. Press unpause, listen to the explanation. Make sure that you also take into account how it was solved and the work that was shown, because that's also important for being able to do the work correctly. The first question is a Pythagoras question. It gives you a right triangle with 3 sides. Now, there are 2 ways to solve this. The first way, and the one that probably most people solved, was they probably drew squares onto each of the 3 sides. And what Pythagoras said, the area of the squares attached to the legs, those 2 areas of squares added together, will always equal the area of the square attached to the hypotenuse. So since the side length of the square is 5, its area will be 25. And since the side length of this square is really the hypotenuse and it is 15, the area of this square will be 225. So this square's area plus the square we don't know's area equals 225. So through subtraction, 225 take away the square we know is 25 will mean that this square's area is 200. And therefore, the length of x is the square root of 200, or approximately 14.2-ish, maybe? I don't know. I'll see. Let's take a calculator, press 200 and say, what's the square root of that? And it's 14.1. I was way off. 14.1. As long as you use the approximate symbol, because it's not actually equal to that because we rounded. So it's exactly equal to this, but approximately equal to this. And of course, the second way we could have done it is to write the theorem itself, a squared plus b squared equals c squared. Typically, this is A, this is B, and this is C, but it doesn't matter which one your A and B are. So we're going to use, I'm going to actually choose this to be my A and this to be my B, and I'll show you why. So x squared plus 5 squared equals 15 squared. I usually like to have my variable term first and then my constant second. So x squared plus 25 equals 225. And at this stage, what you would do in algebra is you would subtract 25 from both sides to get rid of your constant. X squared equals 200. And then you would square root both sides. The square root of x squared, what number multiplied by itself is x squared? The answer is x. And what number multiplied by itself is 200? Approximately 14.1-ish. Question 2 is fraction operations, especially with order of operations. There are 2 operations here. One's addition, one's division. The first thing we learn to do is follow BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. Remember, there are 4 steps. There's brackets, there's exponents, there's division, multiplication in the order you see them from left to right, and there's addition, subtraction. You see them in the order from left to right. So the first thing we have here, since there are no brackets, there are no exponents, we see a division. So we're actually going to solve that first. I'm going to bring the 1/5 plus down, and I'm simply going to solve this division question. So we learned to solve division of fractions by changing the mixed fraction to improper, changing division to multiplication, and using the reciprocal of 4. So the reciprocal of 4, since 4 is really 4 over 1, the reciprocal of a number means you reverse their numerators and denominators. So the reciprocal of 4 is 1/4. So that whole statement up here, 1/5 plus 1 1/2 divided by 4, if I rewrite it like this, it's the exact same question, just a little bit easier to use. Then we keep our 1/5 and we multiply our numerators and we multiply our denominators to get 3/8. Now at this stage, this question no longer is grade 8 level. It's now a grade 7 question because we have addition of fractions, which require us to find a common denominator. The first common denominator we'll use, or the lowest common denominator we can use, is 40. But you can use 80, you could use 120, you could use a whole bunch of different numbers. 40 is the lowest one that we can use. And what we do then is we create equivalent fractions to each other. So 1/5 and 8/40 are the same value. And we can always show that by taking a calculator and saying that 1 divided by 5, or 1/5, is equal to decimal 2. And 8 divided by 40 is still decimal 2, so they are equivalent as decimals. 1/5 and 8/40 are equivalent. If I multiply this by 5 and this by 5, I get 15/40. Again, if I take the calculator just to show you, that 3 divided by 8, or 3/8 is a decimal, is decimal 375, and 15 divided by 40 as a decimal is still the same. So these two fractions here are equivalent. And if I have 8 40ths plus 15 40ths altogether, I would have 23 40ths. Add the numerator and keep the denominator, and that is lowest terms. Question 3 asks you to find the approximate square root of non-perfect squares. So 39 is not a perfect square, which means there is no number that multiplies by itself to get you 39. But there is an approximate number that you can multiply by each other to get 39, and the way we found that was by using a number line. So what we do is at the end of each of these, we find which two perfect squares does 39 really fit between. And the two it fits between is the square root of 36, which is 6, and the square root of 49, which is 7, excuse me, not 6.7, 7. So right off the bat, the square root of 39 will fit somewhere between the square root of 36 and the square root of 49. This would be the square root, this would be 6.5, which would be midway between there. And the square root of 36 is only 3 away from the square root of 30, the square root of 39 is only 3 away from the square root of 36, and it's 10 away from this. So it's probably, if I was guessing, somewhere around there on the number line, which I would have to guess would be 6.2, 6.3, something like that. And if I take my calculator to check it, just to make sure I'm right, the square root of 39 is... So really, the way we wanted to solve this was by being able to figure out that I do know perfect squares, and I do know what their square roots are. And I do know that the non-perfect square of the square root of 39 can be estimated by approximating its location on a number line. So in this case, we did a pretty good job of estimating the square root of 39 is around 6.2. Question 4 gives you a table of values. Of course, we know from our experience. So the table of values, I probably should have been a little bit more explicit with what the instructions should be, but this is a table of values. First of all, is the relationship linear? Yes or no, could have been a question. If it is linear, then there is an equation that can show the relationship between each ordered pair, between 10 and 90, 15 and 100, 20 and 110, if it's linear. So the first thing we ought to do is determine, is there an equation that shows the relationship between all pairs? And we learned that in order for there to be a relationship, there will be a relationship between the value of x and y, and there will be a coefficient and maybe a constant, or maybe neither, or maybe one, that will show the relationship between the two. So the first thing we always look for is the coefficient for x that shows the relationship, and we do so by determining the difference in the y column divided between the difference in the x column. So the difference of y is 10, and the difference of x is 5, and 10 divided by 5 is 2, and that is the coefficient that will go into the equation that shows the relationship between each pair. That's the first thing we figure out, is what is the coefficient. And then the second thing we do is we take any one of those three ordered pairs, either 10 and 90, x is 10, y is 90, x is 15, y is 100, and x is 20, y is 110. We take any one of them. I'm going to take the first one here. And I'm going to substitute the value of 10, which is x, and the value of y, which is 90. And I'm going to simplify both sides to see if they're equal. And if they were equal, that means that we do not require a constant. But if they are not equal, then we require a constant to balance the two sides. And in this case, I will require adding 70 to both sides to make them equal. And therefore, the equation that shows the relationship between the ordered pairs is 2 times the x value plus an additional 70 will always equal the corresponding y value. So it is a linear equation. And once we know that, then in order to find when x is 100, what's y, we take 100 and we substitute it for the x and we simplify it. So 2 times 100 is 200 plus an additional 70 is 270. So the missing y value when x is 100 will be 270. Our next question is an algebra question. It says 3 is equal to negative 10 plus a fifth of x. Now, when we first learned this, the first thing we did is we learned how to draw that. And you don't have to have this drawn on yours, but I want to send you back in memory lane to remind you of what this looked like when we first did it. So positive 3 is on this side of a scale. Negative 10 is on this side, and a fifth of x. Now remember, that if this is x, a fifth of x is only that much of x, right? So we have 3 is equal to 10 negatives and a fifth of x. Now our goal in algebra is to isolate the variable, which means we want to get x by itself. So we want to get rid of everything else that's on that side of x so that we can have it by itself, and whatever's on this side will be its value. So the first thing we want to do is get rid of this negative 10. And I'm just going to grab this whole thing and move it over here for a second. I'll move it way up here, and then we'll show you. So if I'm going to get rid of that negative 10, what I really want to do is add a positive 10 to that side, because it goes back to our grade 7 days of integers. And 10 positives and 10 negatives make 0. Numerically, or using numbers, we're going to do the same thing, but we're going to add 10 on both sides to create a 0 pair. This will still be left, which is a fifth of x is equal to, if I put 10 on this side with it, there are no 0 pairs, and I have 13. Now, how many of these right here does it take to make a full x? It takes 5 of them. So numerically, I'm going to multiply this side by 5 and this side by 5. And I have x equals 65, which is the value that it is. So x equals 65. Now, what you should probably have done, and most of us stopped doing this after we really mastered the idea of algebra, is take your answer. I'm just going to bring all this stuff over here because it's no longer needed. Take your answer, x equals 65. Take the 65 and substitute it where the x was, and see if this is true. See if these two sides are equal. So really what we have here is a bedmass question. Negative 10 plus 65 divided by 5. Well, 65 divided by 5 is 13, so negative 10 plus 13. 13 positives and 10 negatives would be 3 positives, so it does work that the value of x has to be 65. Your next question is, what is the volume of water in this rectangular prism? So this is actually a two-step question. It's first of all, can you find the volume of a container? And secondly, can you find a partial volume of that, or 40% of a number? So the first thing we need to do is the volume of a prism, of any right prism that we studied, is the area of its base multiplied by the height of the prism. That's the formula for any right prism. Rectangular prism, cylinder, triangular prism, or cube. So we take the area of the base, and the base is actually a rectangle. So it's going to be length times width multiplied by height, or 12 times 8 multiplied by the height of the prism, which is 5. It'll be 96 multiplied by 5, which is the same thing as 100 times 5, which is 500 less 20, which is 480 cubic centimeters of space that would be in a full rectangular prism. And remember, we learned that for water, 1 cubic centimeter of space is the equivalent of 1 milliliter of water. So therefore, this could also be thought of as being 480 milliliters of water. So that's the first question. The second question is, what is 40% of 480? So 40%, so if we think about what 40% is, it's 40 out of 100, which we're doing right now, or it's 4 over 10, or it's 0.4. All of those things are the same thing that 40% means. For purposes of calculating percentages, we're going to use decimal 4 as an alternative to the number 40%. And of, as you can remember because it's written on our wall, is a mathematical way of saying multiplication. So decimal 4 times 480 will be the same thing as finding 40% of 480. So decimal 4 times 480 is 192. And therefore, there's 192 milliliters of water in that container. Now, alternatively, in grade 7, you learned that 10% was simply move the decimal one place. So instead of finding 40%, you find 10%. And 40% is really multiplying that 10% by 4. So multiply this by 4, and you would still get the same answer of 192. Carry your 3, right? Either way was fine. Our next question gives us a cube, or we can assume it's a cube. Oh, yeah, it does. It says cube right there. How much to make this cube? So the first thing we need to realize is if we're going to make it, we're going to make it out of like a plastic or wood or something. And it currently tells us the price of a square centimeter of whatever material we're using to make this box is 4 cents a square centimeter. So it doesn't say find the surface area of this box, but you have to know that to make a box, you're going to require surface area, not volume. So the formula for the surface area of a cube, side squared is actually one face of the cube, to make one face or one square. And the coefficient of 6 is to include all 6 faces. So the formula for the surface area of a cube is 6s squared, or 6 multiplied by this edge length of 10 squared. Now again, we have bed mass here. Brackets, exponents, division, multiplication, addition, subtraction. Some people think these are brackets, but they're not. They're just there to separate the multiplication and the exponent from everything else. So that doesn't count as this b. There is an exponent, and the exponent is 2, which means we solve that first. And 10 squared is 100. So our exponents are done. And now we have a multiplication and division, which gives us a surface area of 600 centimeters squared. So the first part of this question is to determine the surface area is 600 centimeters squared. And once we've done that, and the second part would be to take our surface area and multiply it by 4 cents, because 4 cents per centimeter squared will tell us the cost of making this particular container. 600 square centimeters multiplied by the cost of 4 cents per tells us to make this particular box, out of whatever material it is going to cost us $24. Your next question is simply this up here. What percent does this picture represent? And this is actually what we're doing right now. All right, there's a little bit of correction there because I had the wrong picture. So what percent is this? Well, if this is 100 squares here, and what I like to always imagine it as a gas tank, then 100 squares full would be one full gas tank. So here we have 5 parts, 1, 2, 3, 4, 5. 5 parts out of 100 filled, which is really 5%. 5 parts out of 100 because percents are out of 100. And then we have this partial percent, which is magnified to show you that it's half full. So we have an additional 0.5%. So together, this would represent 5.5% or 5.5%. Okay, what percent is it? It's either 5.5% or 5.5%. All right, our next and I think our final question has to do with proportional reasoning. And this is what we call a proportion, right? We have a rate over here and we have a rate over here. And this little equal sign says they are proportional. That's what we learned, all right? So the cost of 5 items, whether they be pencils or whatever, is $12.80 for 5 of them. And then it says that would be proportional to how much money for 32. And there are a couple different ways we learned to solve this, and I'll share with you the different ways we did it. So the first way we learned to do this is to take our, that's not what I want at all, is to take $12.80 for 5 and figure out how much it was for 1. And we could do so by dividing by 5 and dividing by 5 and taking my $12.80 and dividing it by 5 to figure out that each of those items is $2.56. And this is what we call a unit rate, or the cost per 1, or a unit cost. And once we have the cost of 1, it's very easy to get the cost of 32. All we have to do is multiply that cost for 1 by 32. Take our calculator, say $2.56 for 1, multiplied by the 32 of whatever it is I'm buying. The final cost would be $81.92. And this is what we call the unit rate method. Okay, that's one method. The second method we learned, and I'll do it up here, is to take our $12.80 for 5 and figure out how much it was by 32 by figuring out what did I multiply 5 by to get 32. And again, if I was to make it simpler and just make blank over, I'll make it 5 equals something over 20, I would know I multiplied it by 4. If it wasn't 32 but 20, I knew I would multiply it by 4. And how did I get this besides knowing that 5 times 4 is 20? Well, I could take whatever number this was and divide it by this number to give me my multiplier, right? So because that's true with a simpler question, the same procedure, taking this number, dividing it by this number will give me this number, will hold true. So if I take my 32 and divide it by 5, no, that didn't do that right. If I take my 32 and divide it by 5, it tells me 6.4. So therefore, I multiplied 5 by 6.4, and if I multiply $12.80 by 6.4, $12.80 multiplied by 6.4, it should say the same answer of 81.92, and it does. So therefore, x would be 81.92, okay? That's part of our proportional reasoning thing, is just figure out what did you multiply a number by to get another. So that was the second method we could use. And the third method we learned to use was the algebraic method, which is the one I think most of us kind of gravitate towards because it's the neatest and it always works. And the y is not so as important as it works. So if you multiply across your proportion to your variable, you create one side of an algebraic equation. So 5 times x is 5x. $12.80 multiplied by 32 is 409.6. And then to isolate the variable, I will divide both sides by 5. Take your 409.6 and divide it by 5. And you still get the same answer of x equals 81.92. There's your question, and there's your 3 ways to solve it.